In this video, we're going to look at parabolas, specifically through a conic sections lens. Everything in this video is centered at the origin, and they're going to open up or down, meaning they have a vertical axis. So as we derived in a prior video, equations of parabolas in what's called standard form for conic section, which is a little bit different than in, say, algebra, are of this form. X squared is equal to 4 times p times y, where p is this little number here. It is the distance between the vertex at 0, 0, and this invisible point we call the focus, which is at 0, comma p. So p is some number, it's a distance, and it actually can be negative. And p is also the distance from the vertex to this directrix, which is the horizontal line with equation y equals negative p. Now, if your parabola opens down, right, then your point right here, P is actually negative. Notice P is less than 0 versus positive. And it opens down, so the focus is down here, kind of inside the parabola, and the directrix is the horizontal line up above the parabola. All right, so let's practice working with that equation right there. So first, what we're going to find is the standard equation for the parabola with vertex 0, 0 and focus 0, 2, and then we will sketch its graph. So we're going to start with just the general form of the standard equation, which is x squared is equal to 4 times p times y. Now, we are given that the focus is at 0, 2. So we know from that P is equal to 2. All right, we can derive that because the y coordinate of the focus is the distance from the vertex, which also has a y coordinate of 0, to that point. So therefore, P is positive 2. Okay. And so we can plug that in and we get x squared is equal to 4 times 2 times y, or more generally, x squared is equal to 8y. Now, in an algebra class, you would likely solve that for y, which is fine, but we're just kind of taking a different approach here. Now, since p is positive, I do want to note, since p is positive, the parabola will open upward since p is greater than 0. So the first thing I'm going to plot is, in fact, just that focus. So we're going to go up 2. I don't need to really go too far, but the focus is right there. I'm just going to sketch in a few little points here, make that a little bigger. All right, so from there, we're going to go also make sure we go down 2 because the directrix will be down here because it's equidistant from that focus. The directrix will have the equation y is equal to negative 2. Now, the parabola is the set of all points that are equidistant from the focus to that. So we know it's got its vertex at the origin that we were given. Now we can plot a few more points just to get a better picture here of what is going on. And you can just plug in a couple of values. For example, if we plug in y is 1, let's say, if we'll do a little XY chart here just to get a couple of points, right? So I'm choosing y because that's a little easier to solve, right? So if y is 1, then x would be 1/8. We solve that for y, right? Y would be 1/8 x squared. That might be easier. So if y is 1, or rather, let's do x is 1, then y is equal to 1/8. That is easier. 1 squared times an eighth is an eighth. If x is, let's say if y is equal to, no, let's say x is 2, right? Because 2 squared is 4. 4 times an eighth is 1/2. 4/8 is 1/2. And then maybe you can kind of get an idea from that, right? Now, here's a number that's a little bit close to 1, right? So if we choose x to be 3, 3 squared is 9, times an eighth would be 9/8. That's pretty close to 1. So just for getting an approximate graph here, we would graph 3 and then, just slightly above 1. Or, of course, it's symmetric about that y-axis, so we could also plot a point over here. And I think that's good enough for the graph. It's a pretty wide parabola. Okay, and just to review the geometric definition here, right? Any point on that parabola is equidistant from that focus. Let's label that. That is the focus at 0, 2 to the directrix straight down here. Those two purple lines I just drew are equidistant. Okay. All right, let's do one more example of a parabola here. We're going to find the focus and directrix of this equation. Now I've got the picture right here you can already see, but let's figure out how do we actually find that focus and how do we find that directrix, right? So given the equation y equals negative x squared, I would first put it in standard form, which is the x squared is equal to the 4 times p times y. Okay, so to put this in that form, we want to solve for x squared. So if we just take y equals negative x squared and we multiply both sides by -1, we'll have negative y is equal to positive x squared. So notice I have x squared equals 4py and x squared equals negative y. So we can set those coefficients of y equal. So 4p has to equal -1. And if we solve that for p, then we get that p is equal to -1/4, which is less than 0 or negative. So notice it is below the x-axis down here. So the focus then, the focus is, we still have the vertex of the origin. So the focus is at an x-coordinate of 0, and then down from there, a distance of 1/4, but it has a negative y-coordinate, so its coordinates of the focus is 0, comma, -1/4. And then the directrix is always on the other side of the parabola. It never intersects the parabola, right? So it's up here, and it is the line y equals positive 1/4. Okay, and as you can see there, it's a little bit difficult, right? But pick any point here. That distance is equal to that distance. We go straight from there to there. All right, and then the directrix in general, you can see now that the directrix is always going to be y is equal to the negative of the p-value, which we also had listed right up here. That's why we have that negative sign. It's on the opposite side of the x-axis.